Okay. Yeah, again, you always have the opportunity to write down your questions and then send it via email.
Okay, Torben, thank you. Thank you very much. Thank you. Welcome again.
Yeah. So now, yeah, as all the presentations we've seen, we had the brew house, we had the hop star, which is after the cellar, we had the propagation that is in front of the cellar. Now we have a system for pasteurization that can actually be used. Yeah, we also have cider producers that use it to sterilize their media. So what is called wort in the brewery, they just mix things together and then sterilize that. Yeah, so instead of a brew house and having a heat treatment, they are heat treating it in this way. But the main application of our pasteurizer is actually in front of the filling. So after your beer filtration, if you want to make sure that you got a real hygienic and good beer for a long shelf life, you can use our flash pasteurization system. This is available obviously in different sizes. But you can actually see it, and this here has an option with, I will show that, with a buffer tank. So the buffer tank after sterilization in front of the filler. So if there's anything wrong with the filler, you don't need to shut down the system. The heat exchanger is for heat recovery, recuperation that I mentioned for afterwards. And we have actually the holding column to get the PU units that you want to apply to your beer. So let's go through it. So the flash pasteurizer system enables you with efficient heat treatment and stabilization of carbonated liquid products such as beer mixed beverages, ciders, and we're going to hear something around that new topic that arises, also hard seltzers as well. For ciders and hard seltzers, I just mentioned the wort preparation is a little bit different, so therefore these pasteurizers are also at the beginning of the process. For all the others, they are mostly likely at the end of the process, just right before the filler. So the beverages are processed in a controlled continuous flow with the required temperature for a defined time. The main purpose is eliminating of spoilage microorganisms that could be present in the beer. So, and we are focusing on microbiology, safety, quality, and flavor stability. We are capable of handling a wide range of pasteurization loads. It's fully automated, modular, and skid-mounted systems. The standard skids are for pasteurization volumes between 2,000 liters per hour and 90,000 liters per hour. Customized, we can also go further down. So we have the beer formula down here that I guess most of you know. It's sometimes very important to mention that because there's a beer formula and there is a juice formula. They are a little bit different, so we always need to be clarifying which ones should be used in the system because that is going into the software. As I said, very often if you have like ciders or hard seltzer brewers, sometimes they want to pasteurize using the juice formula, and then we have to reprogram our HMI. Okay, so what's your customer value in here? It's the process safety. You get the system is designed with the consistent use of mix-proof valves to prevent any recontamination. So I mentioned the mix-proof valve in the word line from the propagator as well. So this system, because it's in the end of the process and we are sterilizing a product or we are pasteurizing a product before it goes into the bottle or the can, we want to make really, really sure that there's nothing unhygienic. So it's all designed with mix-proof valves. We are applying a positive pressure gradient over the heat exchanger, which means that the pressure of the sterilized liquid will always be kept above the pressure of the non-sterilized liquid. We are using the heat exchanger with recuperation, so the sterilized liquid that is hot is used to preheat the liquid going in to get the best energy efficiency out of it. But to avoid recontamination, if there is a seal broken on the heat exchanger, there's always going to be a positive pressure gradient. So what only can happen if there is a leak, the sterilized or pasteurized product would go into the unpasteurized product, not the other way around. There's an integrated sterilization in place in the facility, so we can ensure the integrity on the production side. So the efficiency, it's a steady state standby mode that minimizes energy and utility consumptions on interruptions. So one part of that is the buffer tank. So if the filler shuts down, there is a buffer time that is roughly 15 minutes. So if the filler will be operational in 15 minutes again, we don't have to shut down the system. Further on, we can somehow adjust the system on the PU units, so in the flow rates, to maximize this standby time, put it that way. But even if that happens, yeah, so we would shut it down and leave it running on water, so we're not wasting the energy. So we're not doing start-stop, we're just doing push-outs again after that. So the heat energy recuperation can be up to 96%, depending on which heat exchangers we're using, a 2 or 3 section heat exchanger. There are various options available for further increase sustainability and minimize the total cost of ownership. Yeah, which we would in the individual case then discussed with you guys. So in the end, we get 13 different other options available that can be added to the system. But this would lead to a long presentation if we would do it here. So that's why we left it away at the moment. And if you got teased by this, again, you come back and we will support you with any knowledge that we have. So what are the main components? So the EcoFlash system typically consists of the following components. So we get the flash pasteurizer module. So with a high head centrifugal pump, a centrifugal booster pump, the external holding columns, which are here, yeah, the recirculation hot water set, including pump and heat exchanger, this is here, and a panel mounted control system for the automatic operation, which can be seen here. Yeah, double optional triple stage heat exchangers with regeneration, heating and cooling sections, as I mentioned, to get the recuperation of energy up to 96%. And the buffer tank that I mentioned is an option as well to with the operational advantages that I just mentioned. So now a little flow diagram that you can see here. Yeah. So with the heat exchanger for heating and cooling of the product, the buffer tank, and the other options. So typical key figures are we are using bright beer with like 5.5 grams per liter of CO2. And maybe that's what I wanted to mention. Sorry, I forgot that when I said can be used at the beginning of the product. So preparation of wort for the hard seltzer or ciders. Then we don't have any CO2. What makes it complicated here is the CO2 with that temperatures. So that's why the operating pressure is up to 16 bars. Because as soon as we're increasing the temperatures, the pressure is rising. Yeah, so capacity is up to 30,000. So this one has capacity up to 30,000 liters an hour as an example. And there you can see the turn down ratio that we build into the system. If the capacity is 30,000, the turn down ratio on, to maximize buffer times and stuff can go down to half of the flow. Yeah, so, and you see there's an adjustable PU range as well that we can calculate. That is, normally it's 1 decade, so from 10 to 100 or from 100 to 1,000. Yeah, so in the pasteurization temperatures are 70 to 75 degrees in this case. You can also ask us to use 80, 85 degrees, that will work as well. Yeah, and as I said, the net buffer time by using this buffer tank is roughly around 15 minutes. Yeah, so you can have a 15 minutes shutdown on your filler and the system will still be operational and you can directly start again sending pasteurized beer to your filler after that. So some technical features, as I said, we get a precise control of the pasteurization units as an essential safety factor. There's a perfect interaction between the different control loops, yeah, to really ensure a superior control of the PU accuracy that we have. Yeah, we get a level dependent flow control, yeah, which I just mentioned. So that increases the buffer capacity and reduces product losses. So if the buffer tank would be filling up because there's a shutdown of the filler, the flow can be turned down, as we said, in the factor 2 to 1. So the flow will be reduced to actually extend the buffer capacity. Yeah, there's a consistent pressure regime, ensures that we always have a positive pressure. That's where the booster pump is for as well. Positive pressure over the heat exchanger to never have a recontamination of your product. Yeah, there's a sophisticated handling of interruptions and errors, yeah, so that we ensure a high process safety and minimize the losses. The CIP process is completely integrated, and there's a sterilization concept for highest hygiene standards inside the flash pasteurizer. All the design with the mix-proof valves and stuff is based on the proven EDG principles. Yeah, we get the variant D4 special valves to ensure the maximum hygiene, and we get a prevention of cavitation and noise emission. Yeah, when we're using the flow control valve with a 3-stage seat to reduce the velocities and to also reduce the noise that you're then getting when you are, sorry, increasing or decreasing your flows. So, at a glance, and that's the end of that presentation. And again, as I said, we have a presentation that I can probably run through with you for 1.5 hours, discussing all the different options. So if that is any interest for you, yeah, just please come back to us, and we will contact you and discuss your needs that you have. Yeah. So the beverages are processed in a controlled continuous flow with a defined temperature and time range to get to the PU units you want. The main purpose again is eliminating any spoilage microorganisms for your beers. Yeah, we are focusing on microbiology, safety, quality, and flavor stability in the beer. We are capable of handling a wide range of pasteurization loads with one unit. As I said, 10 to 100 of PU units. It's fully automated, modular, and skid-mounted systems, and the standardized systems are in the flow rates between 2,000 and 90,000 liters an hour. Again, as I said, we also already built smaller units. That is then a little bit of individual engineering, but we are working on a project where we are trying to standardize a completely smaller unit in a DN25 configuration as well.